Ice ages. Why we have ice ages on our planet? Was that there always? Or is just recent? What the causes? What the evidence is? Let's talk about that. First, let's have a look on the modern planet. We have a large continent, Antarctica, entirely covered with ice. Several kilometers of ice. We have a lot of ice in Greenland, covering mostly all of the island. Many other islands around the northern pole covered with ice. We have ice sheets still preserved in some mountain areas. What does it tell us about our planet or climate right now? Yes, we're in the stages of ice ages. Just right now, the glaciers happen to be retreating up into the valleys, melting, with some periodicity changing during the last several thousand years. But we are in the periods of ice ages on our planet during the last 2.5 million years. We know that Antarctica has been under the ice at least for 34 million years, and the recent glaciations happening for the last 2.5 million years. How do we know that, and why it's happening? We know it from the all records that geologists, paleoclimatologists, geochemists finding all around the planet. We have evidence like in the landscape, in the sediment, on the bottom of the ocean we have particular sediment that we can date and reconstruct the climate of the past. We can collect the ice cores from the modern ice which preserved, younger in Greenland and old in Antarctica, and we can see what's happening up to last 450,000 years with the climate on our planet. And analyzing the chemistry of the elements, we can understand how temperature changes and how the climate changed. So what's happening? Why the planets start experience glaciations? There's many causes of that. First, if you have a look, talks about formation of the solar system and our planet, all that will affect the climate of the planet. First of all, originally from formation of the planet, cooling it down, the surface, appearance of the oceans, formation of the atmosphere, the solar activity changes since its formation, the amount of energy that exerted by the sun, the amount of the energy that produced within our planet, effect of the neighbor planets on the movement of the planet around the sun, all this will affect, in general term, the climate on the planet. For example, we know we have cycles of rotation of the planet around the sun, and they're not stable from year to year. They vary, the changes. So we have changes of the tilt of the planet, we have changes of precession. So like any other object which you spin, the planet keep rotating because she keep rotating and she moves around the sun, and there's other bodies that move around like planets, meteorites, asteroids, which will affect the movement of our planet, and as a result all these changes will cause climate change. Then you have the changes energy that comes from the sun. We have cyclicity within the sun itself. We have periods when the sun more active and it's affect our climate, and when it's less active. We have changes of our core. Our core is metal and warm, and with its formation the magnetic field of our planet affected. And in the long term, our planet is cooling down. At the same time, sun energy is increasing. But we are, as a planet, moving further and further away from the sun as well. So all these factors should be counted to look in the climate of the planet. And then you will think about the space which our solar system traveling through within the galaxy, effect of all the impurities in the space which traveling through with a very high speed. All that and more, which we can't even imagine, will affect the change of the climate on the planet. With the continental crust formation, oceans and continents, these factors will affect dramatically the climate as well. For example, we know recently the start of the recent ice ages as well was attributed to the modern position of the continents, when before continents was kind of clumped together into the one big continent around the equator. We had the oceans on the poles, lower mountains, and less chances for ice to be trapped in the mountains, and the different currents, and as well heat transformation through the water and atmosphere on the surface. As a result, different climate was in the past. Now when the continents rearrange the way they are now, higher mountains and more continent mass land closer to the poles, preferably worked for ice to accumulate around the poles and the ice easier to grow. For example, if you have high mountains closer to equator, first of all, the snow line, the level where the ice will stay over the next summer, will be much, much higher. So you have much more feeding area for the glaciers to grow. Have a look at the video about the glaciers. As a result, in modern continent rearrangements, we have more areas with higher mountains, closer to the colder areas, so the glaciers can grow faster even in modern temperature conditions. And as a result, they start working as a feedback. More glaciers covering bigger surfaces, more ice cover reflect the sunlight, and as a result, temperatures cooling and the glacier continue to grow. Thus, for last 2 million years, we have periods of ice growing, covering a third of our continental surface on the planet, and then melting away, and then growing again, and then melting away. And we call it glacier periods. Periods between the glacier when the warmer event happens, glacier melted, retreat fully or just a little bit, and then come back again with a stronger force or not, repeated and repeated for last 2 million years, and we have absolute precise record for last 500,000 years due to the preservation of ice in Antarctica. The older ice on the planet does not exist, so we don't have solid evidence for older periods. But nevertheless, we can see it's absolutely happened periodically, and some scientists noticing that it correlates with astronomical position of our planet, how it rotates around the sun, its changes, its orbital movement, its axis tilt, and as a result, it correlates with the cooling. At the same time, there's more complicated systems that are affecting the glaciations on the planet. Atmosphere composition, dust in the atmosphere can be attributed to the volcanic eruptions. And we know about 2 billion years ago we have an event when there was a lot of eruptions of volcanoes, much more than now. And some scientists suggested, just by finding some rocks in the bottom of the ocean, that Earth was covered all with the ice. It was a long-term cooling event on the planet. So to summarize this short video with a lot of information, we can have a look on many suggestions what can affect the climate on our planet. Astronomical causes like formation of the Earth, distance from the Sun, effect of the Sun effect, structure of our solar system, movements, mechanics within the solar system, how we move around, changes, and so on. And the long-term cooling of the core within our Earth, increase in sun activity towards its middle ages, and also traveling of our solar system through the space. Within the planet, we have effects of volcanoes themselves, ocean, amount of water on the surface, atmospheric composition and changes, the surface of the planet, proportion of the continents and oceans in their position, depending on how close they're to equator and to poles, how many mountains we have, and as a result, formation of the ice. All these factors bring us to the ice ages which our planet experienced in the last 2 million years. If you think in the global terms, we are in a period for our planet when the temperatures are very cold and we experience periodically the ice ages. Although scientists predicted the next ice age will be at least in 50,000 years, not so soon, we still mentally should be prepared that in the future there will be another ice period on our planet. It will be a strong one or a weak one, we don't know. And if human activity will affect this ice age or the astronomical causes will overtaking and cool our planet more, so it doesn't matter how much carbon dioxide we have in the atmosphere, there will be ice age. We don't know for this stage, but we should be ready for whatever outcome gonna come. See more videos on glaciation and ice age. There's so much to talk about to better understand climate and the history of our planet.